This video is about sketching quadratic graphs and how we can use different forms of the quadratic to give us information about the different features of the graph. We've done some of this before using the factorised form to find the x-intercepts, but now we're going to have a look at how the completed the square form can also help us identify some features of the graph. So let's start with the factorised form. So I'm starting with the graph y equals x squared minus 6x plus 8. So if we factorise that, we're going to get x minus 4 and x minus 2. So this form gives us the x-intercepts, and if you remember, they are also sometimes called the roots. Why do they give us the x-intercepts? Because the x-intercepts are on the x-axis, and on the x-axis y equals 0. So if we put y equal to 0, we have a quadratic equation which we can solve, which gives us x equals 4 or x equals 2. So they are the x-intercepts of the graph. The y-intercept comes from the normal form of the quadratic, this form up here, and it's just the number on the end. So that's going to give me my y-intercept. The other information we can get about the graph, if you remember, is the sign of the coefficient of x squared. So if the coefficient of x squared is positive, we've got a happy graph, which is the right way up, and if the coefficient of x squared is negative, then our quadratic graph is upside down. So let's go to our graph down here and let's sketch on the graph and mark on the x and the y-intercepts. So remember, with quadratic graphs it's often easier to draw in the curve and then mark on your intercepts. So it doesn't have to be to scale, but I'm just going to mark on my 8 on my y-intercept, and my x-intercepts are 2 and 4. Now sometimes we're asked for the equation of the line of symmetry of the graph. So if I draw in the line of symmetry, we should be able to see that the line of symmetry is going to be halfway between the x-intercepts, halfway between 2 and 4. So the equation of the line of symmetry here is x equals 3. Sometimes it's also useful to know the coordinates of the bottom of this graph. So this can be called the vertex or the minimum point of the graph. If we had a graph that was the other way up, it would be called the maximum point of the graph. So we can see, because the minimum point of this graph lies on the line x equals 3, it's halfway between 2 and the 4, it's got to have an x-coordinate of 3. Knowing the x-coordinate, we could work out the y-coordinate by substituting x equals 3 back into the equation of our graph. So if I take that x equals 3 and I substitute it in, I'm going to get 3 squared minus 6 times 3 plus 8, which will give me 9 minus 18 plus 8. 9 minus 18 is minus 9, plus 8 is minus 1. So I now know I can pop that minus 1 in there, and my y-coordinate of my vertex, or my minimum point of my graph, is minus 1. What we're going to do now is we're going to complete the square on our quadratic expression and see how that links into the graph. So if I'm completing the square, if you remember, I'm going to halve it, so that means halve the minus 6, which gives me minus 3, put that inside my bracket squared. Then I'm going to square my minus 3, which gives me 9, and subtract it. So I've done my halve it, square it, subtract it, and then I'm going to pop my plus 8 on the end. So what I end up with is y equals minus x minus 3 all squared, minus 9 plus 8 is minus 1. Now what we need to notice here is the minus 1 on the end of our completed the square form is the y-coordinate of the vertex, sometimes called the minimum point. Okay, so that comes from the number on the end of the completed the square form. If I'm just going to grab a green, how then do we get the 3? How do we get the x-coordinate of the vertex of the graph? Well, that comes from this 3 inside the brackets. But what we need to be careful of with the x-coordinate is we need to change the sign. So I've got a minus 3 inside the bracket, but my x-coordinate is plus 3. Okay, so this gives me my x-coordinate of the vertex but change the sign. So the factorised form will give us the x-intercepts. From that we can also get the line of symmetry. The normal form will give me the y-intercept, and the completed, the square form, will give me the coordinates of the vertex or the minimum point, and that also gives me the line of symmetry. I've realised that you couldn't see the bottom right hand corner of this whiteboard over here, so you couldn't see how I used the symmetry to work out the y coordinate of the minimum point, so I'm just going to do that over here. So we had, by just using the symmetry of the graph, we had the x coordinate equals 3, and we can substitute that into the equation of my graph, y equals x squared minus 6x plus 8, which gives me 3 squared minus 6 times by 3 plus 8, so I get 9 minus 18 plus 8, which is minus 1. So that gives me my minimum point of 3 minus 1. So that is one way to find the minimum point, but what is really the most conventional way now of finding the minimum point is to use the completed the square form that we did up here, and that's what I would like you to have a go at. So as a reminder, we've got the minus 3 in that bracket of the completed the square form. We switch the sign of that to make it plus 3. That gives us the x coordinate, and then in orange the number on the end, which here is minus 1, gives me that minus 1, the y coordinate of the minimum point.